Modern data pipelines are massive, and the Databricks ecosystem has expanded to cover every stage of that journey, from raw data ingestion to governed AI models. The central choice you face today is a structural one. Do you stick with the traditional imperative stack or migrate to the newer declarative serverless model? Choose wrong and the consequences hit fast. You're looking at bloated cloud bills, endless hours babysitting infrastructure, or hitting hard technical walls where your codebase isn't supported. Databricks architecture splits into three vertical layers: infrastructure for compute, execution engine doing the math, and orchestration directing when to run. Data pulls upward from infrastructure through the execution engine, while orchestration manages traffic. At every layer, you must balance granular control against automated convenience. Building pipelines is about explicitly matching the platform's abstraction level to your team's operational capacity. Let's start at the foundation: compute. Here, your primary choice is between classic and serverless. With classic compute, engineers do the heavy lifting. They manually size clusters and manage the compute plane entirely within your own AWS or Azure accounts. Serverless flips that model. This decision matrix shows the difference. Serverless spins up secure clusters instantly, scales automatically, and drops idle billing to zero. But automation requires a trade. You lose custom cloud settings and specialized private networking. Serverless drastically reduces developer friction. But if your enterprise requires strict custom network compliance, classic compute is absolutely mandatory. Moving up the stack, we hit the execution layer. For years, Spark's Tungsten project has provided bare metal memory management to keep workloads moving. But now there's Photon, a specialized vectorized C++ engine built specifically to accelerate SQL and data frame workloads. This matrix shows Photon's speed. Instead of processing row by row, Photon processes large columnar blocks, accelerating heavy joins and parquet writes. The catch? Photon consumes Databricks units at a higher premium. It isn't universal. For custom code, stateful streaming, or fast queries, it transparently falls back to standard Spark. This is a budget risk. You wind up paying the higher Photon DBU rate, but receive no performance acceleration for that specific task. When configured correctly, these engines act like a high-speed bullet train, seamlessly bypassing a congested rail yard, avoiding standard processing bottlenecks. Photon is an incredible accelerator, but it's only a smart investment for massive datasets and long-running queries. Otherwise, it's wasted spend. Now we reach the top layer, orchestration. This is where the debate between declarative and imperative design is the most intense. The legacy imperative approach uses job workflows. Here, engineers explicitly define every single task, hard-code the dependencies, and manually set the cron schedules. Compare that to Delta Live tables. With DLT, you simply declare the desired end state. The platform automatically maps dependencies, scales infrastructure, and absorbs change data capture streams automatically. But DLT has guardrails. It locks your pipeline into Python and SQL, removing your ability to execute Scala code. If you need to make external API calls or trigger custom machine learning models, those non-table tasks still require the explicit control of job workflows. DLT is a specialized tool for pure ETL and ELT pipelines, but for complex multi-system orchestration, traditional workflows provide the flexibility to manage external APIs and custom logic. Finally, we have the operational requirement to monitor the health and output of these pipelines using SQL alerts. Instead of waiting for complaints about a broken report, SQL alerts watch for a 5% revenue drop or a sudden spike in null rates, catching anomalies before bad data ever reaches downstream BI dashboards. These alerts automate crucial data quality checks. However, you have to invest upfront time to calibrate your baselines. Otherwise, your team will drown in alert fatigue. There is no single best Databricks stack. Success depends entirely on matching these tools to your team's specific profile and constraints. On this profile matching flowchart, the modern Agile team prioritizes speed and minimal management. They route straight to a stack combining serverless, DLT, Photon, and SQL alerts. This yields the fastest time to market, but the trade-off is higher vendor lock-in and compute costs. Next, we have the custom legacy engineering hub. These teams have strict requirements for Scala, custom RDDs, and complex cloud networking compliance, so they route directly to classic compute and job workflows. They retain absolute system control and full legacy support, but in exchange, they inherit the heavy operational burden of manual cluster sizing and DAG maintenance. Finally, consider the data ops and BI heavyweights. Their focus is managing massive query volumes, ensuring fast concurrency, and meeting reporting SLAs. Their optimal stack is serverless SQL warehouses powered by Photon with rigorous SQL alerts. They ensure maximum speed for their end users. The trade-off is that they must rigorously monitor their systems to prevent short, simple queries from needlessly burning through that Photon DBU premium. You shouldn't blindly chase serverless or DLT just for the hype. To build a reliable data pipeline, you must ruthlessly match the platform's abstraction level to your own team's engineering capacity.